Great, so we're back from a break here. Ryan Vollum here and Cale Teeter with me. And here in Module 6, we're going to be talking a little bit about designing a management, monitoring, and business continuity strategy. So just to give a brief module overview, we're going to start the module off talking about System Center Azure architectures. We're going to move on to talk about maintenance, then jump a little bit into disaster recovery and business continuity strategies. From there, we're going to move into Azure Automation and PowerShell workflows. And then at the very end, we're going to wrap it up talking about Azure Automation configuration. And we'll do some demos there. Great. So getting briefly into System Center, we're basically going to start off here. We're going to talk about evaluating hybrid and Azure-hosted architectures for System Center deployment. So we're going to run through a bunch of different deployments that actually use System Center with Azure. So as everyone watching likely knows, System Center is a set of server products aimed at specifically helping corporate IT administrators manage a network of servers and client deployment systems. And part of the product suite is System Center Configuration Manager. We move on to talk about System Center Operations Manager, which I'll address a lot more in the coming slides. It also includes System Center DPM, which is Data Protection Manager, and System Center Virtual Machine Manager, which I'll talk a little bit later in the presentation about. So obviously, this product suite is incredibly important to Microsoft and to people who use these products. But as we start moving everything into Azure and into the cloud, we need to start to consider how our architectures are going to change and how we're still going to leverage these same tools in the context of the cloud. So we have to think of about a few different design considerations when actually working with this. So one of the first considerations we really need to consider is bandwidth. So if we've got, for example, an operations database on-premise, but the management server is in Azure, we're talking about generating a lot of bandwidth here, and we really need to be cognizant of that when setting up this architecture. We obviously also want to are concerned about the scalability and the ability to scale of our management servers. We need to consider whether or not we're going to be using a virtual private network, whether or not we're going to be using a VPN tunnel to move into our application. If we are, we're going to be probably using domain authentication. And if we're not, we're more likely to be using certificates and subscription IDs in order to authenticate.
So, Ryan, just to halt there for a second.
Sure.
You just mentioned two different things, right? If we're going to use domain auth or certificate management, do I have to set up like a PKI thing, or what's this certificate management thing about?
So if we're talking about not using VPN, then yeah, you will have to individually manage each of those certificates for each machine.
Okay. Okay. Awesome.
Great. So another consideration we need to think about is whether or not we're using a gateway or whether we're just going to use IPsec. And then, of course, we need to consider what is it that we're going to be monitoring, how much are we going to be configuring, what is the size of what we're going to have up here in Azure.
So on just to stop us another second.
Sure.
So thinking from a customer point of view, this gateway versus direct IPsec, can you talk about that a little bit? Is that a System Center thing or is that an Azure thing? What does that mean? The direct IPsec?
Right. So in order to actually work, monitor Azure machines from on-premise, we either need to, directly monitor these machines and set up all these certificates that I previously mentioned, or we can set up a gateway that all these machines are going to report to. That gateway will in turn report to servers on-premise, and we'll be able to run things like System Center Operations Manager.
I see. So the gateway would be, in a sense, a server that we're going to consolidate things through.
Exactly.
And have like a single pipe back to.
Yeah.
Okay.
Which can very often be a very simple, very clean solution. And I'm actually going to jump into an architecture example of exactly that. So in this next slide, what you're looking at here, we've got an on-premise installation of Operations Manager right up here. And we've got some servers or VMs in Azure that we want to monitor. And there's a few different ways we can tackle this problem. As I was mentioning before, one of the ways we can do that, and in this case is what we're doing, is to set up a SCOM gateway. So we've got this gateway server. All of these machines, they report to the SCOM gateway, which in turn, as I mentioned, is going to report to management servers on-premise. So with this solution, we'd have to manage all the certificates related to the gateways and the servers that we're monitoring. But we do have the benefit of having that one gateway server centralizing all the traffic. It makes everything very simple. It makes everything very clean. And it very often might be the best scenario, given your constraints and given your use case.
Yeah, and to interject here, so to try and kind of drive home the certificate-based authentication approach, in this model, what I'm seeing here, Ryan, is we have these SCOM authentication certificates out here on the monitored server, the server that we're trying to monitor or get data from.
Exactly.
And that's actually going to be used when it talks to the SCOM gateway, and then the SCOM gateway is using the IPsec certificate to come back. Is that correct?
That's exactly right.
Two there. Okay.
Yeah. Yeah. So this is just one example of an architecture you might be using in the real world. So moving on from that, let's say we have a situation where we want to monitor an IaaS an IaaS SQL database in Azure. So in this example, we might have some block ports. We can't use 1433 and 3389, but we have this site-to-site virtual private network right here. So we've got, as I mentioned, we've got System Center Operations Manager on-premise. We have this virtual network up in Azure, which has a SCOM agent installed on it. And then we've got this SQL database that we actually want to monitor. So the solution ends up being, behaving very similarly to what it would, the way it would behave on site, on premise, if we were monitoring local machines using System Center Operations Manager. And in the case that we needed to, manage multiple Azure SQL databases, we could use a gateway role like the one I mentioned in the previous slide.
Okay, so in this model, we basically have an infrastructure as a service, so a VM running in Azure that's running a SQL workload. And you're saying that as long as we have a site-to-site VPN tunnel set up, we have this communication back and forth between there where we can simply then just deploy the agent and then use that to bring the traffic back. Exactly,
and this, this might be a great solution if you're talking about monitoring a single SQL database. But when you start working with with a lot more, you might consider using the solution I mentioned before with the gateway server.
Okay.
All right. So, before moving past all this architecture stuff, I want to talk a little bit about the differences in architecture in monitoring PaaS versus monitoring IaaS. So, in this example, we've got web and worker roles, we've got a PaaS instance, and we're going to have our, diagnostic monitor turned on in the actual Azure VM. The monitor is going to retrieve all the logs and diagnostic information and pull that into an instance of Azure storage. And then we're going to go ahead and configure SCOM on site to look for that diagnostic information in Azure storage and pull it into the management server and ops database. So basically, this is the way the setup would look using PaaS. Whereas with IaaS on the other side, it looks a lot more like monitoring with SCOM would look, on site. So you've got all these subscriptions, and you're pulling information about the availability and the health of all these subscriptions, and you're pulling that straight into an instance of SCOM 2012. Now, what I do want to mention there is that with IaaS, with this use case, you've got no collection of performance counters or of event logs for bandwidth reasons.
Yeah. So I'm just kind of thinking through this in my mind, Ryan. The IaaS versus PaaS model that you just laid out here, right? So when we were in the PaaS model, you showed that we were using Azure storage. So is that like blob storage, or what kind of storage are we talking about? So it's a blob storage.
Exactly.
Right?
It's an instance of Azure blob storage.
So do we need to do anything specific to like our web role in order to even enable those things to be written there, or is that something that happens for us, or what's?
That's all taken care of for us in the case of PaaS.
Okay. And so in that model, essentially, we don't have to worry so much about the traffic, it seems to me, because like if we're writing stuff to a blob storage, that stuff can all happen locally inside Azure, and then we have something that's pulling that data at an interval.
That's exactly right, Kale. And that's very often the beauty of PaaS. A lot of this stuff is taken care of behind the scenes for you.
So in the IaaS model, the reason you couldn't do, like you said, you couldn't do events and some of these other things, I can see, I'm just thinking about infrastructures as maybe you have so many servers out there. What if you have 100 servers out there that want to feed back through that pipe? If they were all sending their events, I can kind of see why that might be an issue.
Right.
And where the gateway might fit in.
Right. It would definitely be way too much in terms of bandwidth.
Great.
Cool. So we've talked a little bit about what System Center has to offer in terms of monitoring. But beyond that, as many of you surely know, Azure also has very powerful monitoring tools built into it. So by default, there's minimal monitoring provided to all users, and in any cloud service. And what those minimal metrics really cover are CPU percentage, data in, data out, disk read throughput, disk write throughput, and really any information gathered from the host operating systems on the virtual machines that you're working with. Now, obviously, this can be hugely important and can be very, very helpful data to work with, and you need to know all this stuff. But in the case that you want more, there's also an option for verbose monitoring, where you can receive additional VM performance metrics and further determine how your VM is performing in the context of Azure.
Okay, so you said a lot there, Ryan, and the
Sure.
thing that I'm trying to get through first off is, so we talked about PaaS and IaaS earlier. So does this monitoring that you're talking about on Azure, does that work, whether it's PaaS or IaaS?
Yeah, Kale, absolutely. So it's all built in to the VMs. It's all going to work no matter what. It's all going to be set up no matter what. So that's all taken care of for you, and there's really no extra work that needs to be done on the PaaS or IaaS front.
Okay. And the other thing you mentioned, I just wanted to clarify, you said something about verbose monitoring.
Sure.
So is that something I have to log into the VM, or what if it's PaaS? How do I enable this verbose that you're talking about, this verbose?
Well, again, here the answer is very simple. All you have to do is jump into that Azure platform, jump into the graphical user interface for your VM, and under the Configure tab, all you have to do is select verbose, and it's going to go ahead and give you those extra metrics.
I see. So that's a setting that we set through the portal.
Absolutely.
Okay.
Yeah.
Cool.
Great. So the next thing I really want to hit on is this global service monitor. So System Server offers this, System Center Operations Manager specifically offers these internal synthetic transactions. Basically, what these transactions allow you to do is, hit a web application, for example, following a certain series of steps. So you can monitor, what it takes to log in, how long it takes to log in, or monitor really any given feature. And this can be a hugely powerful tool, and it's obviously very important. But very often, it doesn't end up actually reflecting the worldwide application's performance. And this is because, when people hit this web application from different parts of the world, the performance doesn't end up working exactly the way it would when you're setting up these internal synthetic transactions, when you're setting up this simulation. So what System Center Global Service Monitor offers is a solution to that. It basically takes Azure and runs synthetic transactions from all over the world, or from wherever you specify. So you basically tell GSM, you say, hey, I'm expecting a lot of hits from East Asia. I'd like you to hit it from here, or I'm expecting hits to this web application from all over the world. I'd like you to monitor what the login process takes and how long it takes from all over the place. And then that's going to give you a much more realistic view of how your application is actually going to perform.
Okay, so I've heard what you said here. This is this GSM, this Global Service Monitor. I know that we have some counterpart also in Azure, right? So we have some sort of web monitoring that does something, and it sounds like it's something similar. So in this case, we were able to simulate where it comes from. So if we said we wanted to have a Europe ping that comes from there and hits something in the US or hits something in another area. So you're saying we can pull that off with GSM as well as what we have in Azure?
That's exactly right.
Okay, great.
Yeah. Great. So moving on from there, I want to talk a little bit about application insights, app insights. And this is a subject we could go on about forever, and I believe one of the modules prior to this actually covers it. But basically what App Insights is doing in terms of monitoring is providing telemetry on the developer level. So it provides information about usage, performance, exceptions, crashes, events, synthetic transactions, logs, developers supplied event data, and it's really more geared to this lower level of monitoring. So more about the developer experience. It might gather clickstream data, for example, which can be incredibly useful for user experience information. It might gather, performance stuff, or trends in how users are using an application to determine how maybe to target ads and how you can take information that about usage and turn it into an actual valuable resource. So App Insights is hugely powerful. And it really provides a 360-degree view of the application and helps to keep it available and succeeding.
So In the App Insights model, is this something that's focused mostly on the client? Is it only on the client, or is this something I can run on my server infrastructure as well? So how is that possible?
So you can actually deploy App Insights, for the client to gather this information I was talking about, clickstream data and everything. But you can also apply it on the server side to gather performance data about how the server is performing. So it's not primarily just dealing with this customer data.
Yeah. So you mentioned the 360-degree view, and I think that's the most important part about that is right, that we can cover not just the client, because there's a lot of solutions out there that can collect information about where your client's coming from and what device they're using, and what are some of the specs about that device that's coming through, and we can certainly do that. But I think the important part is we can also do the server side, and we can kind of correlate that together, and we have a central portal for that. So I think that's hugely important as far as from the health of an application. That's part of our life cycle of our app, so I think that's awesome.
It definitely is, and having that central portal, I think, is also something that's incredibly important and something that I'm glad you hit on. All of this stuff, all these monitoring tools are all available, through System Center or through Azure, and it's all right there, and you can work with it all together. So it's hugely powerful to have App Insights, join the ranks along with all these other monitoring tools.
Sweet.
Great. So we've talked a good amount about monitoring. Next, I briefly want to cover options for maintaining Azure VMs, for deploying updates and deploying patches. And something I want to stress before really jumping into this is that when we're talking about maintenance, we're really emphasizing maintenance on IaaS VMs. The reason for that is that PaaS takes care of all these updates and these patches for you. The beauty of PaaS is that it's doing all of this behind the scenes, and you don't actually have to worry about any of that maintenance. So in the next few slides, I'm going to be talking exclusively about the way IaaS VMs can maintain and update on Azure. Great. So the first thing I briefly want to hit on is Windows Software Update Service, and you've no doubt been exposed to this in the past. It's a tool that allows us to push updates to IaaS instances using using WSUS, using Windows Software Update Service. But it's basically an on-premise. In Azure, you can use this on-premise WSUS architecture. You're not going to be running into issues with egress data costs because you're pushing stuff into Azure. You're not taking it out, so you're not going to really worry about costs there. It's all very simple. It's a lot the way, it's very much the way it would perform on site, and it works in the case of having a hybrid scenario. If you're talking about having VMs on site and having VMs in the cloud.
Yeah. So with that hybrid approach. Ryan, can you talk a little bit about what kind of things would inform me if I was, because when I'm thinking about hybrid, I'm thinking, okay, I have some VMs that are deployed up there in Azure, and I also have some stuff that's running on-premise, whether it's VMs or physical servers.
Sure.
Maybe I'm managing those with WSUS right now. So would I have to move my WSUS server up there to Azure to do this, or can I put it on-prem and manage across? How does that work?
You can actually manage both on-premise machines and Azure machines from a deployment on-premise. You can also put the deployment of WSUS in Azure if you choose to.
Okay. Would that do I have to have a VPN tunnel or anything set up in order to do that with WSUS?
For that, you wouldn't have to.
Okay, great.
Yeah. So next, I quickly want to address Azure SSCM. I'm sure you guys have been exposed to SSCM before. It's basically System Center Configuration Manager, and it supports Azure SSCM supports on-premise SSCM infrastructures using a site-to-site connection in this case, or connection from a standalone primary site in Azure VM environment. So these are really the two use cases you'll be talking about Azure SSCM in. And the reason I'm bringing this up here in terms of maintenance is because Azure SSCM does build on WSUS, what we just talked about right now. So we'll push these updates and we'll patch these IaaS VMs, but it also has a slew of different tools built on top of it that you can also use. So you can set compliance settings, you can set endpoint protection, and basically all you really have to do is install an agent of SSCM onto your virtual machine, and it'll allow you to do all this configuration and to do all this monitoring, collect all this data.
Okay, so what I'm hearing is if I have an infrastructure that's already set up and I'm using SCCM right now to manage my my stuff that's running on premises, if I start bringing up some IaaS VMs and I also want to use the same infrastructure to manage those, I can, as long as I have some sort of network connection, this hybrid connection, whether it's a site-to-site VPN or whatnot, as long as I have that, I can just deploy the agent. Is that what you're saying?
Yeah, that's exactly right. And
Okay.
you can do it in terms of that site-to-site VPN. You can also do it from a standalone primary site in an Azure VM.
Great.
Cool. So we've talked a bit about WSUS. We've talked about SSCM, and these are fantastic solutions for patching and updating applications. However, when you're talking about a large app, you're going to have a hierarchy of virtual machines, and you can't necessarily just patch the entire solution using just WSUS or using just SSCM. So you very often have to come up with a custom solution. Without customization, there's no notion of app tiers or really of any infrastructure constructs. So when you're designing a custom solution, there are a few things you want to keep in mind. You obviously want to use supported approaches, so Azure Automation or DSC, which I'll talk about a little bit later in this module. And you want to keep the approach simple and modular. And of course, when doing this, you want to consider, designing certain Azure constructs. For example, in the case of, these IaaS VMs we're talking about, you might set up an availability set so that when you're patching one server or one VM, another one wakes up and takes care of whatever that was taken care of. So your app never goes down. In the case of PaaS, you've got update domains where this is all built in. It's going to build in that functionality. The app will never go down when it patches. But these are all things you need to consider when working with a custom solution.
Great.
Yep. Great. So jumping a little bit off from there, I want to talk a little bit about Azure Business Continuity and disaster recovery. So to give a quick landscape here, to give a quick context about this field, about disaster recovery as a service. In 2013, about $640 million were spent on disaster recovery. We're looking at an annual growth rate of about 55%. And by 2018, we're expecting the industry to jump up to about $5.77 billion. So every 2 years, we about double the amount of data that's out there in the world. Of course, we need to keep this data safe, so we need to spend more money on disaster recovery solutions. And for that reason, there's a lot out there, and there's a lot happening in that field. So before really jumping into disaster recovery in Azure, I want to quickly talk about what we have on-premise. So at the lowest level, at the app fabric, at the data, we've got storage replication. We can replicate data using Windows replication, and it's all very straightforward. A little bit higher up, we've got VM replication. We use HyperV replica to replicate our virtual machines, and then at the top level, we've got our applications. We've got tools like SQL Always On solution and Active Directory replication to replicate everything at this level.
Okay, so what you're talking about here is a lot of on-premise type stuff. I haven't heard a lot of Azure, right? So we're just focusing on. So these are some of the things that we've already had in place in order to handle replication.
And giving that history and giving that context is really going to allow us to more appropriately see where we're moving into Azure and how things have changed in that regard. So I want to talk about Hyper-V Replica. So basically, Hyper-V Replica replicates all changes on a virtual machine to a counterpart VM hosted by a different server. So this accomplishes a few different things. First of all, it gets data off-site. If you're talking about trying to mitigate a disaster scenario, you want your data off-site. Otherwise, you could lose both VMs, your replica VM and your original, and the point would be moot in the first place. It works over any IP-based network, and it basically, like I mentioned, takes a virtual machine and creates a replica of it. And as changes are made on that virtual machine, it updates those changes during a certain frequency to that second one. So what this really provides, I talked about availability sets earlier. It provides the ability to have either planned or unplanned failover. So in the case of planned failover, say that you want to patch that original virtual machine, having this Hyper-V replica set up is going to allow you to patch that. The other one's gonna come alive and it's gonna take care of all the work in that respect. And then once this is patched, you can pull this one up and patch the second one. So that's in the case of planned failover. In the case of disaster recovery, you might have a scenario where you've got unplanned failover. So that original virtual machine might go down, and then that second one steps up and takes care of it. Now, of course, in the case of unplanned failover, the second virtual machine isn't copying all the data instantly, so you might end up in a situation where you do lose some data. But for example, for Server Manager 2012, data is uploaded about every 5 minutes. So this unplanned failover should take care of almost everything that's been done in this original VM.
So that's to your first point on this slide, this asynchronous replication. So the asynchronous is allowing a little bit of room there that potentially could be out of date or isn't synced yet. Changes, like those kind of things. Okay.
And that's something that customers need to be aware of, when they're actually creating these replica VMs. Obviously the data transfer can't be instant. So there is still room for some data loss, but overall the solution is a very robust one.
Yeah, and you mentioned availability sets a couple times now, and I just wanted to call that out because, coming from the PaaS side of the world, I understand things like upgrade domains where we can actually, enforce things so that if Azure itself needs to actually reboot some of these things, let's say we're patching the hypervisor or something inside Azure, so that's something Microsoft's going to do. That's where our upgrade domains would come in, right? So it's not going to affect that.
Right.
But so how does availability sets work? Like you've mentioned them a couple times, but what's the premise there?
Well, basically, you've got the point of having an availability set is that some virtual machine is always available. So that in the case of this failover, or in the case of some disaster, one machine can back up whichever one had data loss or had some issue with it, or was being patched.
So you're saying if I create an availability set in Azure and I have some IaaS VMs, that I don't want them all to go down at the same time, I should put them in an availability set.
Exactly.
Okay. So yeah, because I could see it from your side, from the SCCM side, or even anything else in System Center. If I'm managing that server and I know I'm going to do some maintenance, I myself know I'm doing that, so there's no issue. But keeping in mind that things need to be patched inside Azure, which is going to affect your IaaS VMs outside of your thing. So I think that's a great point about making sure that we have availability sets.
Right, and the Azure portal makes it actually very easy to set up these availability sets. It's as simple as running through the GUI and placing these VMs together in the same availability set.
Great.
Cool, so now I want to talk about Azure Site Recovery. HyperV Replica was a very good segue into this. So as I mentioned, HyperV Replica is generally an on-site solution, but Azure Site Recovery steps in and provides a lot of the power of Azure to replicate these VMs and to keep everything safe. So if you look at this image, here at the bottom left, we've got Microsoft Azure Site Recovery basically orchestrating the backup between your primary site and your recovery site. So in the primary site, you've got that primary virtual machine that you want to be running, and what Azure is basically doing is making sure that everything passes back and forth correctly. It orchestrates the whole process to make sure that on your recovery site, you've got a backup of that original VM. Now, very recently, Microsoft acquired a company called InMage Scout. And we're starting to integrate that into our solutions. So, in this case here on the left, you see that we're talking about Windows Server. We're talking about the ability to pass these VMs over, but they're Windows Server VMs. Now that we've acquired InMage Scout, we're able to do this with VMware as well, which is definitely a hugely important tool. So we can use Microsoft Azure and leverage its power to orchestrate the process of VM backup for VMware as well.
So if I understand you correctly, you're saying in the first scenario we had HyperV servers,
right,
and we had two different data centers, not Azure, right? They're just data centers from a customer.
They're just data centers.
And then Azure's role in this is actually just watching those and orchestrating this failover.
Exactly.
And then you're saying with our second model that with this other product, the InMage, that we're able to actually do the same thing, but we're using VMware. We could actually have VMware targets.
Exactly.
Okay.
So even though Microsoft in general uses Hyper-V, we do offer solutions for disaster recovery, for people who are using VMware.
Great.
And in these two, in these two first examples, we're talking about having multiple sites. So we're probably talking about a company that's fairly large, that can have multiple on-premise sites, without any issue. So I want to bring attention to the third example here, where we've got a maybe a company that only has one primary server site. If they want to do backups of their VMs, Microsoft is also allowing the ability to back up the VM into Azure. So in this case, Microsoft Azure is both orchestrating the backup, but it's also actually storing the VM so that if that original VM crashes, the second one can jump in from Azure. And coming soon on that front, it's not out yet, but we'll be allowing that same functionality for VMware as well in the case of Image Scout.
Awesome.
Great. So quickly, I'm going to talk about Azure Backup. This is something that you've no doubt been exposed to in the past. But normally, when people think about, people's first thought when they think about cloud computing and about Azure, might be backing up. So basically, Azure can be used to take this bottom tier, this bottom level app fabric, this data, and just back it up into the cloud. And it's a very simple solution. You select whatever you want to back up. You can select files. You can select individual folders, and just have them back up at a certain frequency. So what's great about Azure Backup specifically is that it, if you're a small business or a branch office, Azure Backup integrates with the Inbox Windows Server backup tool. And then if you're, maybe a larger company and you're using something like System Center Data Protection Manager, which I'm going to get into a little bit more in the coming slide, then Azure Backup integrates very easily with that.
Okay, so Ryan, you mentioned, so there's if I have a Windows, thinking from a customer point of view, if I have a bunch of Windows 2012 servers, right? Yeah. And I wanted to leverage Azure Backup. I don't want to pay for tapes, and I don't want to, provision disk locally in order to do that. Are you saying I can do that without? Do I have to set up a VPN tunnel or anything again? I'm talking about hybrid.
No, you don't.
Okay.
Just do it straight into the Azure portal.
Okay, great. And these are encrypted. I think one important point too to talk about is, the bandwidth that's required to do this is something that you should be planning for as well.
Yeah, so what's really great about this and what makes it a very efficient system is that, of course, backing up takes a ton of bandwidth. And if you're talking about, backing up in the middle of the day when people are using the internet and they need all this bandwidth, there could be potential problems with that. So one of the things that Azure Backup allows is for you to throttle that bandwidth so that you'll actually be using less when you need to, or, selecting, at what time you want to back up. You might back up at night when that bandwidth isn't going to be used otherwise.
Okay. And you mentioned System Center Data Protection Manager in here, and I think one of the key differences that I've heard from that was that we can do file level backup, right, if we're just using Azure Backup, but something like Data Protection Manager or System Center Data Protection Manager allows us to capture also system state. So I think that's a key differentiator between those two.
Right. Exactly. Great. So in this next slide, I talk a little bit about the process of setting Azure Backup up. I don't want to talk about it for too long because it's all pretty straightforward, and you've probably been exposed to it before. But basically, you just sign up, you install the agent onto your Windows Server 2012. You can register and configure that so that it actually works with Microsoft Azure, and then Microsoft Azure is going to back everything up back into Windows Server 2012. And I think Kale just hit on it very briefly, but it's very important to note that, of course, all this data is going to be encrypted. So while you're recovering or while you're pushing data up into Azure, everything is totally safe and everything is going to be encrypted. Cool. So I'll talk about System Center DPM, very quickly as well. There's not much to mention here, but there are basically, two real use cases for using DPM. You can deploy it as a physical server on-premise on a virtual machine, or you can deploy it in Azure as a virtual machine. And it's basically this feature that's built into System Center that allows for exactly what we've been talking about. It allows for you to protect this data by pushing it into Azure, getting it offsite, and having a backup of it.
Yeah, and I think one of the things I've heard about this that it's kind of a gotcha and you need to consider is if you're going to host your DPM server from System Center in Azure, you have to keep in mind that there's a limitation on how many disks that we can actually have on these VMs. I believe it's 16, if I'm correct. But so we can only have a certain number of disks that can be attached to these things. So if it's going to be holding your data for a long time, probably not a great model, right? Because eventually you're going to run out of space, depending on how much data you have. So I think the model that I've heard a lot of people drive to is if you do deploy it into Azure, it's not a bad model, right? We can deploy and we can run System Center DPM there, and we can attach as many disks as we need. But really, we keep maybe one day or a couple days worth of data just on DPM, and then we use Azure Backup from that DPM server off to get that stuff off of the DPM disk.
Exactly.
And that way we can leverage both of these services. Data's being all kept up there in Azure while we're doing these things. So, but you don't run into that limitation. I think that's a key limitation of the system.
Yeah, you're exactly right, Cal. Great. So the last thing I really want to talk about in terms of disaster recovery is StoreSimple. So StoreSimple is a solution that Microsoft also recently acquired. And it's a pretty cool solution. It basically facilitates a hybrid scenario. It's an actual piece of hardware. It's called the HyperGate array. And you take this piece of hardware and you throw it into your data center. And what that does, it creates this different hierarchy of data. And it looks at data that you use, most often, the most active data, and it throws that into an SSD, into a solid-state drive. So it makes that data very readily available. The data that's less used but still used fairly often, it throws locally onto tapes, onto disks. And the data that you use with the least frequency, it throws straight into Windows Azure. And the beauty of this system is that we're getting to a point where we're hosting so much on site, and data is just growing so quickly that our hosting costs are getting incredibly expensive, and keeping this stuff on site is expensive. And given the fact that we probably only use about maybe 10% of our data on a regular basis, having this data pushed up into the cloud and making it a little bit less available very much speeds up the situation and makes everything much cheaper, very often between 60 and 80% cheaper.
Okay, so I have a couple questions. First
Sure.
off, I think the name is awesome, this HyperGate array. I want it just because it sounds cool.
It sounds straight out of Star Trek.
Yeah, so you're saying this is a physical device. It's like a server that I'm going to put. Okay, and it has some local disks, is what you said?
It does.
Okay, so from an end user perspective, you said that essentially we don't actually use all of our data all the time. So if we had 10 terabytes of data, you're saying that even if we use 10% of it, only 1 terabyte of data is actually active.
Right.
That people are actually changing or using or whatnot. So this device is trying to abstract some of that complexity for us to basically, so we don't have to deal with keep provisioning new local disks. We're going to go ahead and farm that out to Azure, correct? Is that what you're saying?
Yeah, that's exactly right. And it takes care of all of that for you. And of course, you can configure it different ways. You can say, I want this percentage of stuff on site, this percentage of stuff in the cloud, but it does take care of all that for you.
So how does it work if let's say something wasn't accessed a lot, and maybe it's once a year when people do taxes or something, maybe at the business.
Sure.
And so we don't access that data very often. And this thing does its job, it moves it up to Azure. What's going to happen when someone clicks on that file in the future?
Well, it'll pull it down and it'll keep it around for for some period of time, of defined time, based on its activity.
So there won't be an error. It'll just be a little bit slower when it goes to access.
Exactly. It basically serves as like a big cache. It prioritizes the most important data and makes you can access that incredibly quickly. All this stuff in Azure, you're still perfectly able to access. It just takes a little bit longer and deprioritizes it a little bit.
And so from a cost perspective of all this data flying around here, is there any impact on that? Because am I going to pay for this stuff to go into Azure from this device? Or?
Well, remember, pushing stuff into Azure isn't going to cost you anything.
Okay, so it's only egress. So it's only stuff
exactly.
coming back.
Exactly.
Right. Okay, great.
Yeah. So wrapping that up, I want to move a little bit into talk about designing Azure Automation and using PowerShell workflows. So I do want to emphasize here that as far as this test goes, as far as this exam goes, we're not expecting people to be huge PowerShell wizards that know every single commandlet out there, but we do want people to be able to follow the step-by-step procedure of how to write an Azure PowerShell command and how the whole thing works. So I'm going to give a quick demo here, just basically talking about how we end up setting up Azure PowerShell. So in order to use Azure PowerShell, we first need to install the Azure commandlets, which we do through the Web Platform Installer. So if you just type in the Web Platform Installer, it'll pull up this piece of software. It shows you all these different tools, and you can download the Azure PowerShell. You can download Azure PowerShell or Azure PowerShell with Microsoft Azure SDK. And once you've got that, you can pull that tool up. So here's that tool, and
So this Web Platform Installer is going to enable us to download those modules. So there's special modules for Azure for PowerShell.
That's exactly right. So it's going to download these special modules. It's going to download all these Azure commandlets, and what you can then do from here, you can add an Azure account. You can set up your subscription. So from here, I could use Active Directory using this commandlet to log into Azure, and then once logged in, I'm able to basically do anything that I would have been able to do in the GUI, but in this case from Azure PowerShell. And what this really allows us to do, when we've got all these scripts, we can put them all together. We can have different run books, and then we can automate, processes that are error prone, that take a lot of time, and that overall just aren't efficient.
All right, so just to back up a second, Ryan, so you're telling me if I want to manage some of my services up there in Azure, I can use these PowerShell scripts or these PowerShell commandlets that Microsoft has provided. And if I understand the workflow, you're saying we download these things and get them installed.
Right.
And once we install them, we have to do some sort of authentication so that Azure understands who we are,
Exactly.
what subscription we're trying to access, and then from there, then we can go ahead and execute whatever management commands we want to.
Exactly.
Okay, great.
And to hit a little bit more on the authentication side and on actually getting into our subscription, we historically have been doing it using certificates. We go out there, we get a certificate, we import it, and then prove that yes, we are in fact who we say we are. But now Azure is moving more toward this Active Directory approach, where you use the add Azure account commandlet to set everything up.
Yeah, I think that's a great point because it ties in what we talked about earlier with the securing resources. So the RBAC model that we talked about earlier, this is where that kind of plays out in the real world, right? So we're using these roles to control this.
That's exactly right. Yeah. Cool. So tying off that, that's a very good segue to move us into a talk about Azure Automation configuration. So very quickly, I sort of alluded to this before, but there are tons of use cases where you might want to automate a process. Basically, if you have any manual, long-running, error-prone, or frequently repeated task that you want to perform in the context of a cloud environment or in the context of Azure, you can use Azure Automation to step in and do all of that for you.
None of my stuff's error-prone. All right, everything's perfect.
Kale, you're perfect. This is for everyone else.
Yeah.
So beyond just automating. It's a very simple UI. You jump into the Azure portal, you jump into Azure Automation, and I'll show you in a minute. It's very straightforward to use, and you can do just about anything using this automation tool. You can back up SQL Azure on a schedule. You can patch Azure VMs with no downtime, which I talked about earlier. And all of this can just be done automatically. You can set triggers so that certain scripts will run at certain times, and you can create these big runbooks that will take care of all of this for you.
Okay, so you mentioned a couple things there. One was the scripts, right? You mentioned that this automation is powered by scripts. Is that like VB scripts or Perl scripts, or what kind of scripts are we talking about?
It's actually a PowerShell script. So it actually, it ties back to exactly what we were just talking about.
Oh, okay. Yeah. So everything that I'm going to deploy through Azure Automation, I'm going to use PowerShell in order to write these. And you call them runbooks? Is that the term you use?
Yeah, we call them runbooks.
Okay, so because coming from an on-premise world, I know that we have a tool orchestrator.
Exactly.
That does something similar. Is this very similar? Or?
So you could pretty much just say that Azure Automation is orchestrator for the cloud and for Azure.
Okay, great.
So it offers that same type of functionality, those same runbooks, but now in the context of Azure, Microsoft
Great.
Azure. So I quickly want to show you guys the portal, and if we can, we'll run through an example of a runbook here. So here's our Azure portal. Of course, here are all the services we have available, and you're going to go ahead and hit the automation service. You can go ahead and create a demo. I've already got one here laid out for us. So you jump in. Once you jump into your actual automation, you can hit your runbooks and see all the runbooks that you have there. In this case, we don't have any there yet. So I'm going to pull in a runbook that I've got here on my desktop. It's basically just a hello world application. It's going to be very simple, very straightforward. And then you see that populates right here. So now we've got this runbook in our automation. We can jump into the runbook, and in order to actually run it, we need to publish it. So here's our runbook. Here's the example of the code. You've got these comments here talking about the hello world, and you can go ahead and publish that. Hit yes.
So when you initially imported it, we can't schedule it or anything until we actually publish it?
That's exactly right.
Okay.
Yeah. So you need to publish it first, and then you can schedule it. You can go ahead and just start it. We'll call it world. And this is going to run for a minute. Rest assured, it will produce the output hello world. But this is basically the steps you're going to take when using Azure Automation.
And so I see this usually as a use case for like if we had something that we want to do as thing, right? As you're mentioning before.
Right.
So this isn't something where I would run some other complex business logic type stuff. This is more around management and being able to schedule these management type jobs.
Right.
Okay.
Exactly. Great. So the last thing I want to talk about is, let's pull this up here, is PowerShell desired state configuration. So when you're working with very large systems, you're going to have a lot of different servers, a lot of different VMs, and you're going to want to have them, perform some function or, stay in this desired state. So what PowerShell DSC allows you to do is define what that state is, and it's all just built. It's all just built on flat files. It's built on text files, on files, and you configure everything on your servers using DSC, and then all your configurations, stay consistent and stay as these text files. So what it really allows you to do, if you've got this this huge system of different servers, is prevent configuration drift. So you might find yourself in a situation where Kale might step in and change the way a server is configured, and that can mess up the whole application. What it'll go ahead and do is jump in, take it back to its original configuration, resolve any dependency issues with these other servers, and keep the entire system in the same desired state. What's also really fantastic about this is that it really facilitates the development process. So you can have all your servers configured a certain way in your dev environment, and then you can go ahead and push that same configuration into your test environment. Remember, all these configuration files are just text files. So you can just push that all over. It's going to behave the exact same way, and then you can push that over to production, and it really saves a lot of time there and is an incredibly powerful tool there.
Great.
So to run through some of the functional examples of what we can do with DSC, here's a quick list. I'm not going to bore you with the details, but really what's awesome about it, and what I've sort of hit on already, are these last two bullets, and that's that DSC has the ability to discover the actual configuration state on a given node, and to actually fix that configuration if it's drifted away from this desired state. Cool. And still in the realm of configuration management solutions, I want to hit on the fact that Microsoft wasn't the first to hit this space. There are a few different open source solutions out there, namely Chef and Puppet Labs. There are a few others as well that basically serve the same functionality. So in the case of Chef, you've got what you call these recipes, which are really scripts. And you've got these recipe books, which are really run books, that keep everything configured the same way and keep all these servers working the way they should. In the case of Puppet, you've got the same thing. You've got another crazy name. You've got the Puppet Master, and basically that keeps these servers in those consistent configurations and sets them up exactly the way you want to.
So you just mentioned two things there, right? So these are open source products. Sure. That have evolved, and they kind of perform this same type of thing that DSC does. So
right.
It's managing state configuration. So as a customer, why would I choose System Center over just using Chef or Puppet then for this?
Sure. So the beauty of just choosing the DSC over Chef or Puppet is that you've got all these other solutions. You've got, I hit on it earlier. You've got maintenance solutions in System Center. You've got operation solutions. You've got monitoring solutions. You've got disaster recovery solutions. And if you then use DSC in this same solution, you've got everything in one place. Mm-hmm. It really reduces the complexity. It really makes everything simple. That said, I don't want to detract from the power and value of both Chef and of Puppet. Because all these recipes are out there, because all these Puppet scripts are out there, instead of somebody having to come in and set up a custom scripts to set up configuration, they can just use any of these pre-made scripts, and it's all done very easily. So depending on who you are, depending on what solutions you're using, DSC might be the best call, or if you're not using many, System Center projects or products, for example, you might be more incentivized to use something like Chef or Puppet, which have been around for a little bit longer.
Okay.
Great. So that wraps up this module and wraps up the entire talk. I hope you enjoyed our module, and I hope you found this entire talk very helpful.
Yeah, and the thing that we're trying to drive home here is we hit on a lot of points today with all the different modules. I mean, Ryan and myself covered a few of them here, two of them, but we had some other colleagues doing others as well, and 6 modules here, we basically covered the outline for the exam, right, in order for you to be able to kind of ace this exam. But really the point is, at the end of the day, you need to get your hands on these tools. You need to get your hands on everything that we spoke about here today. Get some experience with these tools and understand the details of them.
Right. So we really planted the seed there. We skimmed the surface, and we hope you'll look at everything a little bit more extensively. And we wish you great luck on the test.
Thanks, everyone.